Okay, we are going to look at lesson 10.2, part 2. We're going to continue working with parabolas, but now we're going to move the vertex from the origin. So now we will have a vertex at h comma k. We will be looking at parabolas of the form y equals a times x minus h squared plus k, where a could be positive or negative. If it's positive, our parabola will go up. If it's negative, our parabola will go down, just like in the previous section. And our vertex is at hk. We'll also be looking at parabolas of the form x equals a times y minus k squared plus h. So if it's in this form, our vertex is still at h comma k, but in this case, if a is positive, our vertex will open, our parabola will open to the right, and if a is negative, our parabola will open to the left. So let's start by finding just the vertex for these three parabolas, keeping in mind that our vertex is at h comma k and using these two formulas. So in this case, our vertex is just 1, 3. Just match it up straightforward to this. For this one, our vertex is -2, -6. And that's because we have x minus h, so that will be minus -2. Another way to look at it is, whatever's inside the parentheses, you change the sign. Okay, this one looks more like this, and I see that my h is on the outside this time. Your h term, the outside term, is going to correspond to this, which is x, and this term will correspond with what is inside the parenthesis. So 7 corresponds with x. My vertex is 7. This is my k, so 7, -2. So for the rest of these problems, if we're looking for a vertex of a parabola, we want to get it into this vertex form. So for the first example, we're going to graph this parabola and identify the vertex, focus, and directrix. Now I see that for this problem, I'm going to zoom in a little. I see that it's already in the vertex form. That makes it nice. So then let me look at everything I know here. I'll start with my vertex. I know that my vertex, which I'll just label as V, this looks like this to me. My vertex is going to be 3, 1. So I'll just plot that. 1, 2, 3. Okay, my vertex. Okay, so let's see here. So I have my vertex. Now I want my focus. So what I need to do is use the same formula we used in the previous section. So that's going to be absolute value of A equals 1 over 4C. Now, from this, I see that my A equals 1/2. So I have 1/2 equals 1 over 4C. 2 equals 4C. And C equals 1/2. Now, because it's of this form, I know it's going to open to the side, and since A is positive, I know it's going to open to the right, which means my focus is going to be 1/2 unit away from my vertex. So that's pretty close. So here it is. Focus 1/2 unit away, and my directrix also 1/2 unit away. Okay. Let me start filling in some of this information. We said the vertex is at 3, 1. Now, in the x direction, my focus is 1/2 unit further in the positive direction. So it's 3.5. So my focus is 3.5, comma 1. And my directrix is going to be 3 minus 1/2. So that's 2, I'm sorry. So it's going to be the line x equals 2.5. Okay, now all we have left to do is sketch a graph. So we have the vertex and focus, we know how it opens, we just need those 2 points. So I'm just going to find 2 times C, just 2 times 1/2. And I know that 2 times 1/2 is 1. So I'm going to go to my focus, and I'm going to go 1 unit up, 1 unit down, and sketch my parabola. Okay, so that's the general procedure we're going to follow for these. Now this one looks different than what we're used to seeing. We're going to be doing the same thing. We just need to get this equation into this vertex form. So if I'm on a test, or I see something like this, and I say, what kind of conic section is this? I know it's a parabola because only one of my terms is squared. So for a parabola, either the x term or the y term will be squared, but not both. So what we're going to do to solve this is complete the square. So if you're looking at this, I'm going to go semi-quickly through completing the square process. If you forget how to do this or would like some review, please refer to section 5.7. So section, I'll write that here, section 5.7 in the Algebra 2 book. That will give you some review on completing the square. Also, for the textbook for this section, for 10.2, there is an example that goes step by step through completing the square. That might be helpful too. So I'm going to keep in mind that I want it to look like this. So I'm going to take my x term and bring it by itself. So I'm just going to move my 4x over. So I will have 4x equals, and then it's going to equal everything else. So 4x equals y squared minus 4y. I'm going to leave a little bit of room and then say plus 16. So in order to get perfect square here, I need to create a trinomial that will give me that. So if you remember what we do here, I'm going to put a parenthesis right here. So remember that negative 4 is my b term. So I'm going to take negative 4 and divide it by 2. I'll show you that step. Negative 4 divided by 2. That gives me negative 2. I take that negative 2 and I square it. So negative 2 times negative 2 is positive 4. And in order to ensure that I'm actually only adding 0, because I can't just add a 4, I'm going to subtract that 4 as well. So I added 4 and I subtracted 4, which is adding 0. So I have now created a perfect square trinomial. So 4x equals y minus 2 squared plus 16, 15, 14, plus 12. Now, this is getting pretty close to looking like this. I just need to isolate x. So I'm going to divide each piece by 4. 4, 4, 4. I now have x equals 1/4 times y minus 2 squared plus 3. Now this should start looking familiar. I see that my a is positive. I have x equals y squared, which means this parabola will open to the right, with my vertex at 3, 2. So why don't I plot my vertex? 1, 2, 3, 1, 2. Vertex. And I'm just going to open to the right. So I need to find my focus and directrix. The absolute value of A equals 1/4c. My A is 1/4. One fourth equals 1/4c. Cross multiply. I'm going to bring this up here and keep working. 4c equals 4. C equals 1. The distance from my vertex to my focus is 1. And we said it opens to the right, so I'll go over 1. That's my focus. So the coordinate of that is going to be 4, 2. And my directrix is also 1 unit away from my vertex, so I'll go 1 unit back. And the equation of that line is x equals 2. So finally, I need to find 2 more points on this parabola. So I will multiply c times 2. 2c equals 2. So 2 is the number I will use. I go to my focus, and I go 2 units in either direction from my focus. 1, 2. 1, 2. And now I'll sketch my parabola. Looks like we've done everything we need to for this problem. Let's go to the next page. So in this problem, they're giving me the focus and directrix, and they're asking me to write an equation of a parabola. So I'll just start by making myself a sketch. So I have my focus of -2, 1. Focus of -2, 1. And my directrix for x equals 4. 1, 2, 3, 4. Okay. So I know my vertex. I know my vertex is in the dead center of my focus and my directrix. Now, what I'm going to do next is I know, once again, that the distance from my focus to my vertex is c. And I know that the distance from my vertex to my directrix is also c. So that means that the distance from focus to directrix is 2c. So 2c, oh, you know what, I'll write it out. 2c equals distance distance between focus and directrix. So let me find that, and then I can find c. So we said that the directrix is x equals 4. So I have x. So my x values go from -2 to 4. So I'm just going to subtract my x values to find my distance. 2c is the absolute value of -2 minus 4. And if you wanted to, you could also just count tick marks. 1, 2, 3, 4, 5, 6. But let's compute the distance so we know how. 2c equals the absolute value of -6, which is 6. C equals 3. So I can use that c to find the equation, to find the vertex, help me draw the picture. So remember that my vertex is 3 units from my focus, and it should be right in the middle here. So I'm just going to plot my vertex 1, 2, 3 units over. So there's my vertex. And so now I know it opens like this way because of the placement of my focus and directrix. So my vertex is at 1, 1, and the form I'm looking for, opening to the left, is going to be x equals -a y minus k squared plus h. So I know that my h and k are 1, 1. And I can find my a since I have my c. So I will use my formula. That's the value of a equals 1 over 4c. Absolute value of a equals 1 over 12. Okay, so now I have that my A is 1/12, so I can just plug everything into my formula. X equals negative 1/12 minus y minus 1 squared plus 1. Let's try another. This time we have the vertex and the focus. So once again, I'm going to start with a sketch. So my vertex is at 1, 2, 3, and negative 2. And my focus is at 3, 4, 5, 6. My focus, 3, 6. So the distance from my vertex, let's calculate the distance from my vertex to my focus. So that's C. C equals absolute value. I'm subtracting my y values to find the distance. Once again, you could just count tick marks if you like. It's negative 2 minus negative 6. So C equals 4. So that means my directrix will be 4 units up from the vertex. I'm not going to need that for this problem, but for practice, that's plotted anyway. So 1, 2, 3, 4. Okay. And they're not asking me to graph it, but I'm just going to draw something in so I have an idea of what I'm looking at. So I know my C, I'll put a little box because I need that. I also know which form I'm using because my parabola is opening downwards. So I'm looking at y equals negative a because of the downwards, x minus h squared plus k. And I know my h and k is given to me. I just need to find a again. So I'll use my formula. A equals 1 over 4c. A equals 1 over 4 times 4, 1 over 16. Now I have my A. I can just plug in. Y equals negative A, negative 1 over 16. X, and remember H is the x coordinate of my vertex. X minus 3 squared minus 2. And I believe, yes, this completes the notes for lesson 10-2.